Hello guys, welcome back to our channel. Today we are having an interesting fraction series, which is to find the value of the sum of 1/6 plus 1/12 plus 1/20 plus 1/30 plus 1/42 plus 1/56 plus 1/72 plus 1/90. Yeah, so how should we tackle? The first thing is don't panic, and we need to find the relationship between consecutive terms, and normally it belongs to either the arithmetic or geometric series. And now let's revise what is arithmetic or geometric series. The arithmetic series is the difference between consecutive term is the same. So here the sample the difference between two consecutive terms is a constant d. And for geometric series, it's a series where ratio between two consecutive terms is the same. And here, the ratio between two consecutive terms is r. Yeah. Then now let's see whether it is arithmetic or geometric. So we use the difference. We find the difference between the first and second term. So we use the 1 divided by 12 minus 1 divided by 6, which is 1 divided by 12 minus 2 divided by 12, which is negative 1 divided by 12. Yeah. So the difference between first two terms is negative 1/12. And we're going to calculate the difference between second and third term. So we use the third, 1 divided by 20 minus 1 divided by 12, and we are going to find the common denominator, which is 60. Yeah, so 3 divided by 60 minus 5 divided by 60, negative 2 divided by 60, which is negative 1 divided by 30. Yeah. So we can see the difference between two consecutive terms is not constant. So here is not a arithmetic series. Now let's see whether it is a geometric. Geometric, we just using the second term divided by first term, or using the third term divided by second term. Yeah, so second term divided by first term, which is multiply the reciprocal. So is 1 divided by 12 times the reciprocal of 1/6, which is times 6. Yeah, so it's 6 divided by 12, which is 1 divided by 2. Yeah, then we are going to use the third divided by second, which is times the reciprocal times 12, which is equals to 12 divided by 20. Then we divided 4 for the numerator and denominator. So 12 divided by 4 is 3, and 20 divided by 4 is 5. Yeah, so here we can see the first ratio is 1 divided by 2, and the second ratio is 3 divided by 5. Yeah, so it's not a geometric series as well. So this fraction series does not belong to the arithmetic series, nor it is belongs to the geometry series. Now let's look at how to solve this fraction series. It is not a arithmetic or geometric series. There is another pattern, which is we are going to write each fraction as one fraction minus another fraction. Similarly, yeah, and then the fraction, there's a common term. So here we can see in the first fraction, we are having minus 1 divided by b. In the second, we are going to plus 1 divided by b. Yeah, so here we can cancel. Then let's see if we can fit this pattern into this fraction series. Let's observe the denominator first. Yeah, so here we can see the 6, right, can be written as 2 times 3. The 12 can be written as 3 times 4. 20 can be written as 4 times 5. So on and so forth until the last one, 90 is equals to 9 times 10. Here we can see the pattern is natural numbers, and here we can see naturally linked. Here this is the common terms. Yeah, so the problem is, can we write 1 divided by 2 times 3 into 1 divided by 2 times 1 minus 1 divided by 3, or n times 1 divided by 2 minus 1 divided by 3? The answer is yes. So here 1 divided by 6 equals to 1 half minus 1/3, and also 1 divided by 12 equals to 1/3 minus 1/4. How we are going to do it? I'm going to illustrate. So 1 divided by 2 times 3 equals to 3 minus 2 divided by 2 times 3, which is 3 divided by 2 times 3 minus 2 divided by 2 times 3. Then here we are going to divide for the numerator and denominator. Here divided by 3, here divided by 2. Then here we have 1 divided by 2 minus 1 divided by 3. Yeah, so 1 divided by 2 times 3 equals to 1 divided by 2 minus 1 divided by 3. Similarly, 1 divided by 3 times 4 can be written to 1 divided by 3 divided minus 1 divided by 4. It is because the difference between the two terms, right, is constant, is 1, and also the denominator is 1. That's why, and also the common denominator between two adjacent numbers, right, is always 3, the multiplication of these two adjacent numbers. Yeah, that's why we can write 1 divided by 2 times 3 equals to 1 half minus 1 third. 1 divided by 3 times 4 equals to 1 third minus 1 fourth, so on and so forth. And here we can see we fit into the patterns. And here we are going to cancel the term minus 1 third plus 1 third minus 1 fourth plus 1 fourth, all minus, yeah, so on and so forth until we are only having the first term minus the last term. Yeah. So here equals to 1 divided by 2 minus 1 tenth and equals to 5 divided by 10, which is 1 half minus 1. So it's 4 divided by 10. Then we divide by 2, which is 2 divided by 5. Now let's look at the summary of the tricks. The first thing is always don't panic and try to observe the pattern of consecutive terms and to determine whether it is an arithmetic series or geometric series. And here is a recap of the arithmetic and geometric series. Well, the arithmetic series is having a constant difference between two consecutive terms. Here is the D, and also for the geometric series is the ratio between two consecutive terms is the same. Here the constant ratio is R. Here also got the sum of the for arithmetic and geometric series, and if you are keen to find out, you can look for the geometric series. Yeah, and now let's look at whether if the series is not a arithmetic or geometric series, how should we tackle? Then we need to find the pattern of point 3, which we need to observe the denominators and try to make it equals to a times a plus m. Then also the second fraction is a plus m times a plus 2m, then plus a plus 2m times a plus 3m. Well, the difference between these two numbers, right, is always a constant m. Yeah, then sometimes the series may have a misguided information here, then you need to multiply n to the denominators, then you can see the patterns. Yeah, then we are going to use the pattern of the denominator to break it down to 0.4, which is we are having the n here times 1 divided by m. Why here is a m? It's because the difference between these two terms is m, the difference between these two terms is m, the difference between these two terms is m. Yeah, so here we can see is a times a plus m equals to a plus m minus a. Then here the denominator is m, then we times 1 divided by m. Yeah, here is the multiplication. That's why we are having the 1 divided by m here. Yeah, then similarly we can write one fraction into one fraction minus another fraction. Yeah, so here 1 divided by a times a plus m equals to 1 divided by a minus 1 divided by a plus m. Similarly, we can write this second term into 1 divided by a plus m minus a divided by 2 plus m. Yeah, so here, so on and so forth, then we can cancel all these. Yeah, but here just to pay attention, we always have misguided information in the questions, and you may need to manipulate the denominator, extract a factor of n out, then you can observe the patterns. Yeah, and also the two multiplications, the two terms multiply equals to the denominator. The the difference must be a constant. So here we can see it's a m, here we can see also is a m, here is also a m. And also lastly, you need to times 1 divided by m. Yeah. So here is the summary for tackling the series when the series is not a arithmetic or geometric series, and is especially for the fraction series. Yeah, so thank you for watching our videos. If you like our videos, please give us a thumbs up and also subscribe our YouTube channels and also turn on the notifications. Lastly, we have similar questions for those who are interested to try more of this type of question. And if you are keen to find out the answers, please comment in our comment sections and we will try to post the answers in our comment sections. And thank you again for watching our videos and see you next time.